So hello everybody, in this question we are told the points A, B, C are the vertices of a triangle. We write the equations of the three medians of that triangle, check they intersect at the same point, and find the coordinate of that point. Check that this point divides each median in a ratio of 2:1. So we can draw the triangle first, maybe it will help. So we draw the axes, and then it's not perfect, but well, that will do. So I need to draw the medians. So of course there's the x and y axes, and that's one median. So those are the medians, and now to name them, so that's point A, so that's x, and that's y, and that's point A, and that's point B, and point C, then 0, 12. So the midpoints, we can call them P, Q, and R. So P would be 0 and 12 divided by 2, that is 0, 6, and Q 8 over 2, 12 plus 8 over 2, so that is Q 4, 10, so that is 4, 10, and R would be 4, 4. So there's a midpoint, the centroid, that the coordinates of which we need to find. We need to verify that it's the same point at which all of these medians intersect. So we need to find the equation of the medians. So we will start with equation of BP. So equation so that would be, we will use the format y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. Okay, so BP would be y minus 6 is equal to 8 minus 6 over 8 minus 0 times x minus 0. Y minus 6 is 2 over 8, x 1, 4, 4y minus x is 6. So we get, sorry, that's not right. I made a mistake, as always I do. So 4y minus x is 24. So that's right. And then that's the equation of BP. So highlight it. Right. Then I will find the equation of CR. So I will write CR. So that would be y minus 12 is equal to 4 minus 12 over 4 minus 0 times x minus 0. So we get y minus 12 minus 8 over 4 times x, 2. So we get y minus 12 is minus 2x. So therefore y plus 2x is 12. So that's the other equation, and that is CR. So my highlighter. So then we will find the equation of AQ. So say equation of AQ. So AQ, so we will say y minus 0 equals 10 minus 0 over 4 minus 0 times x minus 0. So y equals 10 over 4 x. So 2 times 5. So therefore 2y minus 5x is 0. So that is AQ. So we've got that. So next we need to find the points of intersection of the medians. So we will find the point of intersection of we will find the point of intersection of BP and CR. So let's start with that. So we write to find the point of intersection of BP and CR. So BP, we know the equation of BP. So that is 4y minus x is 24 and CR is y plus 2x is equal to 12. So then I can multiply this by 2. So I can write 4y minus x is 24, and I can write this as 4y multiplied by 4. So 4y plus 8x is 48. So I get, if I were to subtract, I would get minus 9x is equal to 4 versus 2 minus 24. So I get x is 24 over 9. So 3 times 3, 8. So 8 over 3. So we get x is 8 over 3. So now we need to find the coordinates of y. So 4y equals 24 plus 8 over 3. So that is equal to 3. 72 plus 8. So that is 80. over 3. So therefore y is 80 over 3 times 4. So that is 20 over 3. So we get so we have the coordinates of the point O, 8 over 3 and 20 over 3. Now we have to check it with another one. So I can write O is 8 over 3, 20 over 3. So that's this point. Okay? Okay, so 8 over 3, 20 over 3. Now we need to have a check. So we need to do two more medians. So we said BP and PR. Maybe we can say AQ and CR. So I will say point of intersection of AQ and CR. So AQ, CR is here, AQ, where's AQ here? So that is 2y minus 5x is 0, AQ. So 2y minus 5x is 0, and CR is y plus 2x is 12. So y plus 2x is 12. So then I can say two y minus 5x is 0, and then multiplying it by 2, 2y plus 4x is 24, and then minus 9x is minus 24. So x is 24 over 9, and that is equal to 8 over 3. So we get x is 8 over 3, and then 2y equals 5 times 8 over 3, so 4. So therefore y is 20 over 3. So we get 20 over 3 and x is 8 over 3. So we once again get the coordinates of O. O is equal to 8 over 3, 20 over 3. And that's verified, So that's done. So we verified it, that the medians pass through the same point. So we have done that. They pass through the same point. And then we need to find the coordinate of that point, which we also have found. Now the bit is we need to check that this point divides a median in the ratio of 2:1. So how are we going to do that? So we need to find the distance. So if we can somehow find that this distance and this distance, or we could find the one with 0, that's probably easier to handle. So if we can say this distance AO and OQ, and if AO is twice of OQ, then it's proved. So we find AO and OQ. okay, to find the distance AO and OQ. So I'm going to write that. So to find the distance is AO and OQ. So how are we going to do that? Now AO, where is AO? AO, so we know the point O, we know A. So A is 0, 0 and we know O. So A and O is 8 over 3, 20 over 3. So AO would be square root of 8 over 3 square. Okay, and then we need to find OQ. So what is Q? Q is 410. So Q is 410. And O we know. So OQ 8 over 3 minus 4 so now that is equal to 9. So that is 8 minus 12. 20 minus 30 square. So then I can write 8 minus 12 is minus 4. So I'm going to write here minus 4 and then minus 10. So that is equal to square root of 9, 16 plus 100. So then I get that is equal to square root of 9 over 116. So what we need to do is we need to find the ratio. We need to find the ratio AO over OQ. So if I write ratio AO is to OQ is equal to 2 is to 1. So that's what we have to prove, right? So AO over OQ I can do. AO over OQ is equal to, where is AO? So once more my highlighter. So that is AO and that is OQ. So AO over OQ is a square root of divided by square root of 116 over 9. So that is equal to square root of 464 over square root of 116. So I can write this as 106 over 116, and that is equal to square root of 4, and that is 2. Hence AO over OQ is 2 over 1. Therefore AO is to OQ is 2 is to 1. Hence our proof is done. And this is correct. It matches, isn't it? 2 is to 1.